All right, proving triangles congruent by SAS, which stands for side, angle, side. All right. So basically what it says is if you have two triangles and two sides and the included angle, now included means in between. In other words, the angle formed by those two sides. So if you look over here, AB, which is marked with this, and AC, which is marked here, form angle A. Over here, line segment ED and FD form this one, angle D. These are the included angles, the ones that are formed by the sides we're mentioning. All right? So if this and this and this and this and these two angles match up, we have what is called SAS. And if you use this method where you label matching marks and angles, I promise you this will be much easier and there'll be fewer mistakes. All right, so write a proof. Okay, so we're given BC is congruent to DA, and we're given BC is parallel to AD, also known as DA, same thing. All right, so they're already marked. You see BC is right here, and AD is marked here, and you see the parallel. Now, the reason that's important is because if this is parallel, and we look at it this way, not a shape, but if we looked at lines, right? And what we have here is a transversal. Okay? And the beauty thing about that is, if we have a transversal, then our rules that we've learned, alternate interior, alternate exterior angles, come into play here. All right? Now, there's also a very important thing here. This line right here, if you remember, AC is congruent to itself by the reflexive property. Remember, if you look in the mirror and see yourself, you see your reflection. You are you. So AC is equal to itself. All right? So that's a very important thing to have here. So I'm going to say AC is congruent to itself. Now, these two are given, and this is the reflexive property. Now, we know, if we look at this, AC and AD form this angle, and BC and AC form this angle. Those are alternate interior angles. So we can say, by what we already know, angle BCA is congruent to angle, and you got to go in the same order, right? So BCA is going to be DAC. And how do we know that? Alternate interior angles. So we have a side which matches up with a side. Oops, I wrote A. We have a side here that is, equal to itself, and we have an included angle. Well, if you just read it, what do we have? SAS. So we can say now that triangle ABC is congruent to triangle CDA, and we can just say SAS because of side, angle, side. We can prove that. You need to hit pause, go ahead and catch up. All right, in the diagram, QS and RP pass through the center of the circle. So here's QS and here's RP. They pass through the center. What can you conclude about triangle MRS and triangle MPQ? Well, let's see what we know. We know that MS and MQ are equal to each other. Okay? We also know that RM and MP are equal to each other. Not only that, all of those segments are equal to each other because of the fact that they're all diameters of the circle. So we know that QM is congruent to MS, which is also congruent to RM, which is also congruent to PM. They are all equal to each other because they are all diameters that are cut in half by the center of the circle. We also know that this angle right here is congruent to each other, okay? So SMR is going to be congruent to angle QMP, okay, because they're vertical, okay? So what do we have here? We have SAS, SAS. So we know triangle MRS is congruent to triangle MPQ by side angle side. We just kind of did a theorem without the structure of a theorem. Okay? Again, hit pause if you need to. All right, you're making a canvas sign to hang on the triangular portion of the barn wall shown in the picture. You think you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS, and it's marked right here. All right? And you know that PQ is congruent to PS. Those are marked right here. We also know that this right here, RP, is congruent to itself. Okay, and you know that because of the reflexive property. So you also know that these angles are both 90, okay, because they're a linear pair. So what do we have? SAS. So we've just proven it, okay? These are congruent by SAS because of those pieces of information. Okay, exit ticket. You're going to do this on your own, okay? And we'll talk about it in class.